Hi guys, this is 6-1 Solving Systems of Equations by Graphing Part 2. All right, in Part 1, we learned that when you graph two equations, the point that they intersect is the solution to the system. Sometimes you'll have two equations that don't have a single solution, all right? Just like when we were solving equations with variables on both sides, some equations had infinite solutions and some equations had no solutions. And the same thing's going to happen in systems of equations. You can have one solution, which is pretty common, or you can have no solutions, or you can have infinite solutions. And so that's what we're going to be looking at here. Let's see. In your original workbook, you're going to want to be on page 323. Okay. This is an example where you have two equations, a system of equations, and when you graph them, they're exactly parallel. Well, how do you know if two lines are going to be parallel? Well, if they have the same slope, they're parallel. See, this has a slope of 2. This has a slope of 2. Now, remember, our slope-intercept form is y equals mx plus b. This number in front of x is the slope, and this number is the y-intercept. All right? So when we look at these equations, we see that they have the same slope. Now they have different y-intercepts. This one has a y-intercept of 0, and this one has a y-intercept of 15. So that's why this one's graphed up here and this one's graphed down here. But they're changing at exactly the same rate, so they will never intersect, all right? So in the graph shown, there is no intersection point. The system has no solution. Now, you would think it would be easy to spot these, but what they're going to do is they're going to give you two equations, and one of them, one or more, will not be in slope-intercept form. And that's the case here. This one's in slope-intercept form, so we're cool with that one, but this one is not. To get it into slope-intercept form, we have y minus 2/3 x equals -3. Now, to get y by itself, we have to get rid of this minus 2/3 x. We do that by adding 2/3 x to both sides of the equation. That gives us just y on the left. And on the right, we have a positive 2/3 x and a -3 for our y-intercept, right? And that's what they were doing over here in the box. They were trying to show you, you add 2/3 x to both sides, which is what we did, and then you simplify, and then you get it in slope-intercept form, which is this right here. All right? So if this one is y equals 2/3 x -3, we can tell right away that these two equations are going to be parallel lines, okay? Because they both have a slope of positive 2/3, and they have different y-intercepts, all right? So here we were given, they've given us the same equations back. They want us to graph it and see what it looks like. Okay, so this first one has a y-intercept of positive 1, which would be right here, right? And then it has a slope of positive 2/3, which is up 2, right 3. And now we have another choice. We could, when we have a positive slope, we can also make both the top and the bottom negative, all right? Which would be down 2 and left 3. And when you're graphing systems of equations, it's usually beneficial to get as many points as you can because you're trying to find the point of intersection. Of course, we know these aren't going to intersect. So we're going to go up 2, right 3, 1, 2, 3. I'm going to go down to left 3 just to make it easier for me to draw this line. Yeah. Not my straightest, but not my worst ever. This one has a y-intercept of -3, so this would be -1, -2, -3. Also has a slope of 2/3, so we can go up 2, right 3. We do that again. No, we can't. Down 2, left 3. There we go. And now we graph this one. And if I was a perfect grapher, which clearly I'm not, these would be exactly parallel and will never intersect. So when you have a problem like this, the answer is no solution. Just like we did before when we had variables on both sides, occasionally the answer was no solution. And that's what we have here. All right. Check your solution. I don't really get this part. I mean, I did this with the first period class because I didn't have the video made, and I don't really get this part. They want us to subtract 2/3 x from both sides. Well, if I subtract 2/3 x from this side and I subtract 2/3 x from this side, then I get y minus 2/3 x equals 1. And then here, y minus 2/3 x cannot simultaneously be 1 and -3. Okay, so they're saying y minus 2/3 x is equal to 1, and then y minus 2/3 x is equal to -3. Boy, they complicated this. Don't check your solution like this. Forget that. Okay, solve the system of equations by graphing. Well, this one is in slope-intercept form, and we know we have a y-intercept of 0 since it doesn't have one, but this one is not in slope-intercept form. This one's y minus 2x equals 4. We need y by itself, so we need to get rid of this minus 2x, and we'll do that by adding 2x to both sides, which gives us y equals 2x plus 4, because this 4 was positive. Well, we have y equals, and the other equation is just y equals 2x, and we know that this would be 0. So graphing this, we'll graph the first one first. We're going to go up 1, 2, 3, 4, and our slope is 2. So it would be, anytime you have a whole number slope, you put a 1 under it. This would be up 2, right 1, but we can also go down 2, left 1. So we can't go up 2, so we're going to have to rely on the down 2, left 1. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And it's a little wiggly. That's this equation right here. For this equation, the y-intercept is 0, so we start here. And this one we can go up. We can go up 2, right 1, up 2, right 1. Or we can go down 2, left 1, down 2, left 1. Either way, you get a line that is clearly going to be parallel to the first line. So this has no solution. There's no point that these two lines will intersect. Sometimes you have infinite solutions. And what happens here is they give you two equations, but they're actually the exact same equation. Now, you won't know it at first. This first one says y equals 3x plus 5. And the other one says negative 3x plus y equals 5. Now, at first glance, you can't tell if these are the same equation. But once you solve for y and you get this one in slope-intercept form, then you can see clearly that they are exactly the same equation. The slope and the y-intercept are the same. And when that happens, they have infinite solutions, okay? Okay, so in the graph, the lines intersect at all points, okay? The system has an infinite number of solutions. So this, you would graph this one, and then you would graph this one right on top of it. Sometimes if you're using a graphing calculator, like you can graph it one in blue and one in red, and then it gives you a purple line or something like that. But yeah. All right, so here we have a system, and we know we're in infinitely many solutions, so we can pretty much expect that these two are going to turn out the same. This one's in slope-intercept form already, but this one is not. They want us to get it in slope-intercept form by adding 3 to both sides, which gives us y equals 2x, and then negative 2 plus 3 is positive 1. But now we can see that this equation and this equation are the same. All right, so graph the equations. You only have to graph it one time. It has a y-intercept of positive 1 and a slope of 2. Slope of 2 is up 2, right 1, or down 2, left 1. Up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1. And there's that one. And it says any ordered pair on the graph of the line will satisfy both equations, so there's an infinite number of solutions. So they're saying any point on this line works in both equations. So there are infinitely many solutions. Infinite solutions. Okay. All right. So again, this one's in slope-intercept form. This one is not. We need to take y plus 1/3 x equals 1 and put it in slope-intercept form. We need to move the 1/3 x to the other side. So we subtract 1/3 x from both sides. That gives us y equals negative 1/3 x plus 1, which by chance is the exact same thing this is. So we're graphing the exact same equation twice. I'm not graphing it twice. The y-intercept is 1. The slope is negative 1/3. When we have a negative slope, we have a choice. We can put the negative sign on the top number or the bottom number. This is down, this is up, this is right, this is left. Okay, so from here, I can go down 1, right 3, or from here, I can go up 1, left 3. And this is the line. And if I were to graph the other equation, I would do the exact same thing over again, and it would be the same line. All right, now this is an example of a word problem. This is a word problem, and it's way scarier than it looks. The Spanish Club is having a bake sale. You can buy a bag of trail mix and a loaf of pumpkin bread for $11, or 3 bags of trail mix and 2 loaves of pumpkin bread for $24. This situation can be represented with the system, and they've given you the equations, which is pretty nice of them. Usually they ask you to write your own equations, but in both examples in this book, they've given you the equations. Now here's an important part. X is the cost of a bag of trail mix. So X is how much trail mix costs. And Y is the pumpkin bread. Okay, so we have these two equations here. We have x plus y equals 11, and we have 3x plus 2y equals 24. Okay. Well, we need to put them both in slope-intercept form. So we need y by itself. We need to get rid of this x, and we can do that by subtracting x from both sides. That gives us y equals negative x plus 11. That's one equation. For this equation, we're going to have to do a little bit more steps. First of all, we need to get rid of the 3x, so we subtract 3x from both sides. That gives us 2y equals negative 3x plus 24. Then we need to divide each term by 2 to get rid of the 2. And that will give us y is equal to negative 3 halves x plus 12, because 24 divided by 2 is 12. Now this little graph over here just barely does 12. It's like really tough. So this is the other equation here. All right, so the y-intercept is positive 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're going to say 11's here, and we're going to put 12 here. All right. Now the slope is down 3, right 2. So we're going to go down 1, 2, 3, right 2. Down 2, 3, right 2. So try to get some kind of a line here. And this is not the greatest line ever. Not even close. Alrighty. And then the other one I'll graph in blue. The other one has a y-intercept of 11, which is like right here, and a slope of negative 1. Negative 1 says down 1, right 1, down 1, right 1. Okay, now this was not supposed to intersect here. It's supposed to intersect here. Down 1, right 1, down 1, right 1. It's just my crappy line drawing abilities. But these lines are very close to each other. It's supposed to intersect here and then go off over here. So this was our point of intersection, which is 2. Our solution is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. The solution is 2, 9. Now, you'll recall I told you x is the amount of trail mix, or how much trail mix costs. So this is the cost of trail mix. Trail mix is $2. And then this is the cost of pumpkin bread. Pumpkin bread is $9. And that's how we use the solution to answer the question. Here we have another word problem, and clearly it's our last word problem because there's your secret word. But just like the previous one, they give you the equations and they tell you what x and y represent. Chloe skated at an average speed of 10 miles per hour, while Avery skated at an average speed of 5 miles per hour. They skated a total of 20 miles in 2.5 hours. This situation can be represented with the system x plus y equals 2.5 and 10x plus 5y equals 20. And it tells us x is Chloe and y must be Avery. Okay. So now we need to get these in slope-intercept form. Starting with this one, we'll subtract x from both sides. That gives us y equals negative x plus 2.5. And this one, we need to get rid of this 10x, so we subtract 10x from both sides. And that gives me 5y equals negative 10x plus 20. Now we have to divide each term by 5, which gives me y is equal to negative 2x plus 4. All right? So this one is actually kind of tricky. You know what? I wanted to check the teacher's edition too because I couldn't see that this had a definite solution. I'll go ahead and graph these and see if I get the same thing I did in class. This one, the first equation starts out the y-intercept of 2.5, which is awkward, right there. And then it has a slope of negative 1, which would be down 1, right 1, down 1, right 1, down 1, right 1. It's weird because these are all in the middle of the line, all right? So that's that first line. I don't really want to draw the line just yet. Let's graph Avery's. Avery starts at positive 4. 1, 2, 3, 4. That's the starting point for Avery and has a slope of negative 2. So it would be down 2, right 1. That's not a point of intersection. Down 2, right 1. That is not a point of intersection. Down 2, right 1. Not a point of intersection. So you see my problem here is I'm having trouble visualizing exactly where these two lines cross. This one goes like this. And so I'm kind of estimating 1, 2 as the solution. That is a gross estimate because it's not really at 1, 2. It's going to be kind of in between there. Let me check the teacher edition for just a second and see if they estimate the solution too. All right, the teacher's edition says that this is 1.52 is the point of intersection. So 1.5, 2, oh, my lines are so bad. Anyway, they're saying that Chloe is traveling 1.5 miles per hour and Avery is traveling 2. That wouldn't make sense because Avery was going slower, wasn't he? How long did they skate? Okay, Chloe skated for 1.5 hours and Avery skated for 2 hours. Whatever. I don't like this problem at all because of the half thing. That makes it very hard. Okay, so your secret word is summer. If you hop on over to McGraw-Hill, that assignment should be waiting for you. And don't delay because it expires tomorrow. All right. Have a great day and 8 more days. Yep.